Hello, everyone. Welcome to the CIM Users Group Technical Webinar Series. Today's presentation is on CIM as a solution of choice for distribution system operators. This webinar will last 1 hour. Our presenter, Alexander Babs, is from the Institute of Power Engineering. He has 15 plus years experience in ITIS systems implementation, IT infrastructure projects, high availability systems, and ITIS departments management. He's a project manager in the field of CIM deployment in one of the DSO companies in Poland. A few housekeeping tips for our webinar this morning. Mr. Babs will give his presentation, and at the end, he will leave some time for you all to ask questions. You can do that by simply raising your hand in the field on your screen, and we will unmute you one at a time in order to ask your question, in which he will answer. And now I will turn it over to Alexander Babs with the Institute of Power Engineering.
Hello, everyone. It's my pleasure to welcome you to the webinar. It's actually my first webinar ever, so please excuse any mistakes. If I make them, I will try to avoid them. Okay, so I see quite a lot of attendees. Thanks again for attending. And today's webinar will be about the CIM, but more viewed as a solution rather than a standard. So we've been doing some work recently with local DSOs in Poland. So we've gathered some experience, and I think it's a very good opportunity to share the views and experience coming from the projects that we've either completed or are just doing today. Okay, so let's proceed to the first slide. Okay, what can we say about CIM today? So I think CIM today is quite a mature solution for both for DSOs and TSOs. So many people think that it's quite efficient with CIM to integrate some applications and put new applications in place into the application landscape within the companies. CIM has been implemented, tested, and proven in many business scenarios and many business cases. So it's kind of a mandatory standard today to think about CIM when we think about new applications being implemented in a company. CIM is based on a UML model, and today it covers most application integration needs. But this is just a semantic model, and it will never cover all the needs of the company. But luckily, CIM is quite easy to customize and tailor it up to your specific needs. And there are many tools today available to do it. I will later during the webinar, I will try to present the tools that we are using today to customize the CIM UML model and produce the patterns that can be useful for application integration. You can find many examples based on CIM for specific basic needs. For example, you can have very good examples for messages for advanced metering infrastructure. This is 6.1. This is the. I will briefly. It's called Part 9. I will go into this deeper later on. Okay, these were just the facts today as CIM can be viewed today, but at the same time we can also say that it can be quite difficult to start with CIM, because our observation is that the learning curve is quite steep at the very beginning. You need to really spend some time thinking about how to make your first step with CIM. So the aim of this webinar is to provide some concepts and about CIM as a solution, not just in terms of the numbers and standards, but try to picture CIM as a ready-made solution that is up for grabs, or it can be easily implemented or close to easily implemented in the company. I'll try to I will try not to show too many norms and numbers, but some of them will be necessary to present the CIM as a whole. Okay, let's go to the next slide. This is according to Gartner. CIM is being implemented in many. CIM has gained a lot of grounds recently. So we can see that it's the percentage of respondents indicated CIM as a solution that is already implemented or will be implemented is increasing over years. So I think we can see that most of the answers are about the how to use CIM to exchange information between applications, provide means for better data sharing, and also use CIM as a standard to use CIM standard payloads and definitions for the applications that are used within the company. So CIM becomes nowadays an indispensable factor in a software-oriented architecture-based business environments. But it's quite easy to say that, but really how to start the journey with CIM. I'll try to give to show you my experience and my opinion, how we started with CIM and what we're using to carry out projects that are based on CIM. Okay, CIM is a collection of different models and of different packages. I'll try to mention the most important, but please realize that there are many different packages, and these are all defined in the norms, standards that are provided by IEC and can be purchased and then downloaded from the web. So there are packages that are used, that are focused on distribution. This is 6.1.986.11. These are CIM extensions for distribution. There are also packages for energy market operations like IEC 61325. And there are also packages for transmission. This is 61970.301. But of course, there are many other packages. We can mention 61970.452, 456, 453, 457. They all have their specific purpose and are used for specific needs when we need to integrate or put in place, for example, an EMS system that uses topology or steady-state hypothesis or power flow solutions. You can find specific packages for they pretty much cover all the application needs that can be for a company, for a distribution company or for a transmission company. A very good presentation about packages was given last year in Oslo. If you want, please refer to the presentation. It's available on the CIM user group's website. It was the first day. It was the presentation given during the CIM University. Okay, how the landscape looks like this. We have on the top left side, we have CIM in UML. We have transmission packages, distribution packages. We have definitions, how to produce the output files based on a CIM RDF schema. We have definitions how to produce CIM XML based on the XML schema. And but today we are going to concentrate on the I think most common CIM implementation or CIM use, which is the messaging between the enterprise applications based on the definitions that are provided by 61968 parts 3 to 10. I will focus on two of those parts and show how specific messaging requirements can be satisfied using the tools that are freely available today. Okay. So that's what I call, this is where messaging happens. So these are the parts responsible for specific processes, use cases that can be customized and put into use using with CIM. Okay, this is a more colorful picture with the different parts. We can see the customer support, meter reading control, operational planning and optimization, maintenance and construction, records and asset management, network operations, and network extension planning. The other the packages that define every one of those topics. That they cover these areas with specific messages and use cases. Okay. Okay. This is the black and white picture with different parts, 61968 parts, 3 to 9, and we can see that those messages can be exchanged between different applications, either directly, application to application, or with the enterprise service bus, which is called ESB. Okay, so on the top top left side, we can, for example, see distribution management business functions. We can also see distribution network planning, construction, maintenance, operations. There are definitions that cover all of these topics. Okay. Basically, according to the definition, IC 61968 parts 3 to 9 and 13 define the information recommended for message payloads. So all these payloads are formatted using XML, with structures defined using XML schema or RDF schema. According to the recommendation, the semantics of system interfaces of a compliant utility inter-application infrastructure should be defined using UML. And later on I will focus on the UML, how to use it, and what tools can be used to customize or extend the UML model. Usually the transport for the messages can be realized through different means like JMS, RESTful HTTP, or web services. In my opinion, the web services method is the most common one. Message paths can be direct, as I mentioned, directly between two applications, or can be indirect through the service bus. Service bus based implementations are more and more common these days, as they provide some added value over application to application direct paths. Okay, now let's focus on something called interface reference model. And interface reference model is a set of definitions for specific needs and for specific business processes. We have, for example, something called 61968 part 3-3, which is interface for network operations. It defines an interface for network operations with an aim to cover most business processes within operating networks. So, for example, messages that are based on part 3 can be used for things like data acquisition, fault isolation, fault restoration, trouble management, and so on and so on. Let me mention that for most of the messages, there are definitions for so-called interoperation tests. So the interoperability tests. So those interoperability tests are able to help you to find out if the application that is using a specific definition is compatible with other applications using the same definitions. So, for example, you can test if an application application A talks to the application B in the right way, or is it able to understand all the messages that are produced or received between those two applications. There's also another part within the reference model. It's part 4, which is the interface standard for records and asset management. There are also some interoperability tests focusing specifically on part 4. They can all be found on the CIM user group website. So if you need to look into them, there are many sources and slides about the interoperability for part 4. Okay, another definition within the interface reference model is part 5, which is the operation planning and optimization. It's kind of a working draft, and it will focus on interfaces for operational planning and optimization, and it will be applicable for the cases that are listed below that you can see on the screen. Later on, I will also focus on the part 6, which is the one of the most commonly used parts of the interface reference model. And this is used for interface. This is an interface standard for maintenance and construction. It defines an interface dealing with maintenance and construction. For example, you can use part 6 for things like construction work, service work, maintenance work, inspection work, or trouble work. There are specific messages that cover all the needs that can be that are connected with the applications dealing with maintenance and construction in general. I will also focus on part 6 later on during the webinar. Probably the absolutely most common one or most widely used is the interface reference model part 9, which is the interface for meter reading and control, because it focuses on meter reading as well as meter operation and control. And there are more and more smart meter rollouts these days, and utilities are looking for interoperability between different layers of the AMI infrastructure. And part 9 is a solution that is able to provide interoperability between, for example, head-end systems and meter data management, billing system, SCADA system, outage management, and so on and so on. So the projects that we've done so far are mostly focused on part 9 implementation and in NORM. I will also try to use part 9 as an example showing how to handle or construct messages using the tools that are available for specific needs for the AMI application. Okay, let's go to okay, this was part 9. Sorry, I didn't scroll the screen. Okay. This screen is called CIM-based typical integration project, because from our experience, there are specific steps that needs to be taken, or a following scenario can be applied in order to deliver a project. So basically, first thing to do for the integration project is to identify the relevant interface from those that could be seen on previous slides. You need to take specific model and try to confront it with the actual business requirements, or basically the use cases, workflows, and specific needs that you can identify within the company. And then you can take the existing CIM UML model and create extensions to the model if they are necessary. That is, in the case when the relevant interface does not cover all the needs of the company or the information exchange, you need to do your own extensions to the model that can be later on translated into XSD files for the specific messages. Then you should generate data exchange profile. Then you generate message structures in the form of XSD files, which I will show later on. Having the XSD files, you can try to proceed with the WSDL creation that can serve as the exchange points for information between the applications. And then, when you have all the XSD files in place and you have defined all the WSDLs, you can go to the developers and make them write the code that is able to provide and exchange the information that is required. And probably this is the most tricky part, because XSD file creation and WSDL file creation is only a small portion of the whole concept of data exchange between between different applications. So, if you want to build your own CIM profile, there are some prerequisites. Usually, we use Enterprise Architect with the CIM EA plugin installed, and also it's quite efficient to use CIM tool. Although it's worth mentioning that you can create XSD files directly from CIM EA plugin. But we use all those three tools to produce a working XSD files. Okay, these are the steps that need to be taken in order to create an XSD file for a specific message. First, you need to edit your packages with the CIM EA. In our opinion, in our experience, is the most efficient way to deal with the CIM UML model that you can download from CIM user group website. CIM EA is the most effective tool to customize or first select the classes and then customize them or add your own attributes and so on. Then you need to produce an XML file from Enterprise Architect that can later be an input to the CIM tool software. CIM tool is an Eclipse-based software that is able to deal with the OWL and XSD files, and it takes XMI files as an input. I will later show exactly the screens how to for the specific steps from the Enterprise Architect to CIM tool to an XSD file as a result. It's worth mentioning that there is an excellent presentation about Enterprise Architect and CIM tool available on the website. I think it was created around 2008, but it's still very, very good, and it shows all the detailed steps that are required to customize the model and produce a working XSD files. We decided to use CIM EA because, in our opinion, it's a bit more efficient, and this plugin is free, and you can use it to tailor or select the classes and attributes that you need to use for specific messages or use cases. Let's go to the next slide. Okay, this slide here shows you all the common message envelope concept. So basically, we concentrate on the messages are just the most inside part of the message envelope. So the messages define what information is to be sent. Then you need to wrap the messages using the according to the IC 61968-100 definitions that defines how to send the information. Then later on you can have messages exchanged via the ESB enterprise service bus. You need to provide the wrapper level, which is usually a SOAP, and then you also need to think about the transport level that I mentioned before. It's usually HTTP or HTTPS based messaging. So the messages that we create, for example, for part 9, are just in the very that they are the most inner part of the message envelope that needs to be sent between the applications. Good news is that message creation is relatively easy. It gets a bit more tricky with the other parts of the message envelope, but it's also manageable. Later on during the webinar, we will focus on the message on the messages. Okay. First thing to do is once you imported or you opened the CIM module in Enterprise Architect, is to select the CIM EA plugin and then select classes, attributes, and relations to be used for profile building. On this specific screen, you can see the reading type on the left side. That it can be, and you can see all the attributes of that class on the right side. So you can select what attributes you really need, or maybe you don't need. You can also try to add your own attributes if you need them. So this is the customization part. So you can basically take any class you need. You can freely modify the attributes, or bearing in mind that you are modifying the standard. So you always need to think about, is it really worth deviating from the standard? It's a business decision that needs to be taken. Okay, once you created once you customized the classes or the attributes, you can produce the XML file from Enterprise Architect that is an input to the CIM tool. Okay, now we can see you can see the relation between the slide in the previous slide and this slide. We can see that we're trying to build a message called meter readings. And this is exactly what it is a web ontology tree, web ontology language tree with the semantics for specific message, which in our case is a message that will be used to get the readings from a smart meter. Okay. Once we have this, we can see the XSD structure in CIM tool. So we can see the relations between classes and And from we can basically see the message structure as represented by the XSD, and then from that point we can see the text representation of the meter readings XSD file, which is basically the template that will be used to exchange the meter readings data from the between applications. Okay. This is an example for very generic meter readings XSD definition. But let me show you how it really looks in the field between real applications. So I have chosen a very basic example, which is the connection of link between the AMI and SCADA. And this is how it really looks when it comes to a request and response. When one application is trying to get data from the other application, in our case, it's SCADA is trying to get some data from AMI, and these are the request and response parts of the message. So I think it's very well human readable. So you can see when you look into the file, you can see what is really going on and what are the timestamps. What is the operation, which is defined by the verb field, which is request has a get verb and response has a reply verb. You can see the noun, which is the object of the data exchange, which is meter readings in our case. So once you create the request message, you get the response message, which, by the way, can be quite huge, because you can request many reading types from many usage points. So as a response, you're given a matrix of data. So say we have 2 reading types and 3 usage points. So you get in total 6 fields. For every usage point, you get requested reading types. You can also increase the complexity when you try to get the interval data, sometimes called profile data. So as a result, you can get a pretty big XML file containing all the responses for the specific reading types, usage points, and intervals that you have requested with your request message. What is quite important at the first stage is to have a proper naming convention for messages. So once you create many messages and you define many operations, it can get pretty messy. So it's very good to prepare a definition for the naming convention for the XML messages that are being exchanged between applications, and it's just a proposition. We can for the definition we use is the naming convention we use is a web service method name followed by the operation name and an underscore operation type. So it's quite easy to read, and you cannot go wrong with although the script, although they are pretty long, they are pretty descriptive, and you can always decipher what they really are meant to do. Okay, so these are the naming conventions for XML messages, and you also need to observe the naming convention for WSDLs. In our case, it was get meter readings and on the AMI side, and the receive meter readings on the SCADA side. So you can see these are the web service method name that are the first part of the name of the XML message file. Okay. Please refer to all the definitions about the verbs and nouns. The full dictionary is available, that is contained and described in many presentations on the CIM user group website. In this specific case, there are just verbs get, reply, created. So, but there are also other verbs that are used for messaging. Okay. It's worth mentioning that when there is no verb, it's usually a failure or fault message. So it indicates that something went wrong. For example, the message could not be parsed, or it was not adhering to the standard, or simply it was not understood by one of the applications. Okay. Let me show you a very brief process of implementing the workforce management system that needs to be integrated into business environment. I'm going to show some steps in a nutshell how to do it using CIM. So basically the goal is to implement workforce management system that can be easily integrated into business environment. The minimum requirement, there are many other requirements, but let's focus on the minimum requirement. The minimum requirement is that grid incidents observed in SCADA and acknowledged by the SCADA operator should be seamlessly directed to the application, that is workforce management system application, and handled appropriately. Defining the work priority, route optimization, asset info, and so on and so on. So basically, everything that happens and it can be seen in SCADA should be assessed and by the SCADA operator and sent to the workforce management system application that will handle the message and start a process that will finally that will focus on resolving the issue. Okay, so these are quite simple steps and simple definitions, but I think they are quite effective. So, in a tender process, make it clear to the software vendor that the application, that is workforce management system application, should be CIM compatible. So simply it should be able to accept CIM messages in order to start a specific process, like, I don't know, fixing a line or removing the short circuit and things like that. On your own side, you should define desired integration pattern. So you should select the transport, message paths, pretty much provide all the definitions or all the prerequisites for effective message exchange between SCADA and workforce management system that will be implemented. Later on, you should try to define XSDs that will be used for message exchange between SCADA and WMS application, and provide those XSDs to the vendor. It's just one of the ways. There may be also other ways, but this is one of the possibilities that can be used. For example, it takes the load of the vendor, and it puts more effort on your side as a utility to provide ready-made definitions for an application that will be implemented or plugged into the environment. And you can using the widely available tools like SOAP UI, you can test XSDs and WSDLs once the applications are able to service the requests. We use SOAP UI in order to check the input and output of the WSDLs that are used as the service points for message exchange. Okay, as I mentioned before, I'm going to focus on the maintenance and construction. This is the part 9, and this is just the first step, which is to check which definition is relevant to our specific business case. So in our case, for work scheduling and dispatching, there is a ready-made definition within the part 6 definition. Okay, so this is the reference model. For sure, you are not going to be using all of it, but only specific fields. But those specific fields are already there and can be used as a definition for messages that will be exchanged between the WMS and the SCADA applications. Okay. Once you decided which package to use, which parts to use, you can use Enterprise Architect to look into relevant classes and attributes. We can see the relations between classes. We can see the attributes, and if there is a need to add an extra field or an extra attribute or an extra relation, you can always do so within the Enterprise Architect or the CIM EA plugin that I described before. So this is just an UML model that can be customized, tailored up to the specific needs. This is a representation of the part 6 in Enterprise Architect, and these are the descriptions of specific classes and attributes that are contained within the specific classes. So more or less, there are ready-made definitions that probably can be used directly to signal the events between SCADA and workforce management system. For example, we can see the work location class, the asset class, or the work class, or the meter class. So there are more or less, all of them, they are more or less related to a message that will be sent to the workforce management system in order to define what really happened, and will provide an information for start. I mean, information how to start the case within the workforce management system, send the right people to fix the fault, and simply resolve the issue. And once you decided what classes and attributes you're going to use, you need to have the XSDs for the use cases that will be taken care of by the WMS application. For example, like the incident work order from SCADA to WMS application message, or the incident resolution result from WMS to SCADA, and so on and so on. So all the definitions for all the messages need to be created in the form of XSD files. So once you have all the use cases covered with XSD files, it's pretty easy to produce the payload and effectively send messages between the applications that we are trying to integrate. So as you can see, it's not really very difficult to start SIM-based message exchange. It needs some work at the beginning to understand the tools, to make the best use of them. Please realize there are tons and tons of information on the CIM user group website. So this is what we have used at the very beginning to get familiar with the tool set and all messages, and finally we were able to produce our own XSDs and WSDLs for specific needs. Okay, this was the last slide. But before we go to questions, I would like to invite everyone to the CIM User Group Conference that will be held at the very beginning of June. You can see all the information on the CIM User Group website, and hopefully we'll see you there. And thanks for today's opportunity for the webinar. Are there any questions, please? Hello? Unfortunately, the audio was working before, and now it's not. Yes, for sure. Okay. So I think we're limited to chat, and maybe Brittany will take over from now.
Okay, I will read. There's a couple of questions in the chat. Can you hear me, Alexander?
Okay.
One of the questions says, how to identify or detect that the module has CIM or not?
Can you repeat, please? I didn't understand.
Sure. So the question just states, how do you detect or identify that the module has CIM or not?
Okay, this is a very generic question. So basically what we've done before, we've done some audits of different applications that are used in a company, and we try to find out if there are any elements of CIM included or available within the application. So some applications, for example, were able to produce a model with the topology based on CIM, but at the same time they were not able to import the topology information. Some applications have really quite an extensive documentation on their own data model that could somehow be, with the aid of specific tools, could be translated to CIM. So I think it all comes down to a right audit to try to talk to the application vendor and also see for yourself if CIM is in place, or is it used by the application, and to what extent.
I will go ahead and try to unmute the person that had asked that question to see if they have any follow-up.
Yeah, hello.
Yes, we can hear you. What was any additional follow-up to your question?
Hello.
Yes.
Yeah, actually, this is a question that I have asked in the chat, that how to identify and detect that the module has CIM or not.
Oh, sorry, I didn't.
I'd like to explain actually what I mean about the question is.
What I mean by excuse me, what?
Yeah, I would like to explain the question about how to identify and detect the module. It has CIM or not, yeah.
Okay, I think it's this almost the same question as before.
No, I would like to explain it. Actually, the same question I have asked.
Okay, you would like to
Actually,
explain?
yeah,
Mm-hmm.
yeah,
Go ahead.
yeah. Actually, I'm working on a smart grid project, and where I need to have a data exchange on a SIM standards.
Okay.
And the other applications where I should fetch the data, just they comply as they have SIM. So practically, I doesn't know whether the applications have SIM or not. So is there any tool where by myself I can identify whether that application has SIM or not, instead of asking to the manufacturer of that application?
Okay, I don't think the answer is binary, like yes or no. As I said, SIM can be present can be used by the specific application. It can be used to a specific extent, or it also can be the messages that are used by the specific application can be translated back and forth to SIM with the specific adapter. But I don't think there's just a one sentence answer how to check if the specific application is able to handle SIM. You can also try to recognize if SIM is serviced or used by the specific applications by its actions, or is it able to produce SIM messages, or is it able to receive SIM messages. You need to simply audit the application and try to get to know it and see if it's SIM capable.
No, I need to definitely should contact the application vendor.
Yeah, it's very helpful. Yeah, it's one of the steps we do. We ask the vendor if they say yes, we have SIM. We try to talk to them and check what version and what messages are used, or what is the purpose of SIM being implemented by this specific application. But then you're right. Contact the vendor is also a very good idea.
Because in India, in the smart grid sector, they have only SCADA and GIS system, and they want to implement outage management and etc.
Okay.
So for these cases, they are asking us to make SIM compatible and have a data exchange on SIM, on SCADA as well as GIS. So here I am facing the problem. So I doesn't know how old those systems are, SCADA and GIS. So I was I was feeling that there could be something syntax or some messages where I can just extract or detect that the SCADA or the GIS system has SIM or not, instead of contacting vendor.
Likely, the answer is look into part 3, which is the ready-made messages for outage management system. So first, please look into 61968-3, and then you will find quite a lot of messages and structures that are able to handle the outage management system messaging. Okay?
Okay. So there is no other way to detect whether the other applications have SIM or not in that.
In my understanding, you need to first audit the application, talk to the vendor, and see for yourself.
Okay, there is only either audit or talk to the vendor. Those are the two.
I think so. That's what we've done in the past, and I think it was the right way to do it.
Okay. No, fine. Thanks, Alexander.
Okay, so we are gonna we have a few more questions, so we're gonna go ahead and I'll read another question off.
Okay.
All right. So the next question states: is there any detailed document or file which explain more about the different steps for SIM-based message exchange?
Yeah, use the 61968. If I understand the question correctly, this is the -100. It's quite an extensive definition of the methods to actually send the data send the messages, to be more specific, between applications. It's a part of the common message envelope concept, I believe. So it defines how to send the information, and there are also many very good presentations on the CIM user group website describing how to use strongly typed messages, for example, and JMS and HTTP and web services and so on. So if you like, later on I'll be able to provide the sources on the CIM user group that I'm referring to. Just send me a message later on.
Okay, great. Thank you. We have time for one more question. So the question is there any use case where CIM can be used between substation and control centers? What do you see as applications, the result of the harmonization of 61850 and CIM models?
Yeah, it's true. It comes down to the harmonization between 61850 and CIM. But so far we haven't done a project on it. Probably there will be one coming soon. But there's an excellent article on the CIM user group about 61850 and CIM harmonization. So please refer to that. I'm not able to give any more details as an answer.
Great. Thank you, Alexander. And thank you everyone for joining. Just a reminder that we do have a meeting coming up this June. The institute that Alexander works at will be host. It will be happening in Poland, June 1st through the 4th. We'll also be sending out an email to all the attendees. You can register and save an extra $50 off the early bird week, which due end tomorrow. So please take a look at our website and go ahead and register for this conference so that you can get more information about the CIM. And we will be posting today's presentation on our website in just a couple of weeks. So thank you everyone for your time. Thank you, Alexander, for your presentation. And have a great rest of your day. Bye-bye.
See you in Gdańsk.
Bye-bye.